This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. In previous session, we have gone through with different problems onto RDDs. Okay, just have a look. So in yesterday's session, we have gone through with three problems and these problems are solved with the help of RDDs. RDs are nothing but resilient distributed data set and we are not having a proper schema over here and the data mostly like we are dealing with the unstructured data. Okay, however, like we are able to do the analytics on top of data which is given or which is processed in terms of or with the help of RDs, but these are lower level construct inside the PySpark. So RDs are used very less in today's world. However, there are certain benefits which are given by RDs. Okay, say anonymous functions and all. We are using lambda keyword over here. Extensively, lambda keyword is utilized over here. That is nothing but anonymous function. Okay, so anonymous functions are possible with RDs, and in your code, if sometimes you need to apply anonymous functions, then you can convert your data frames to RDs, and then you will be able to apply the anonymous function. So from the anonymous functions perspective, like this is the benefit from the RD side, and but nowadays we are working on to data frames. Data frames, that is the higher order API or higher order construct from the Spark side, and mostly like with the help of data frames we are processing structured data or semi-structured data. Okay, so just have a look. Let me start the day with data frames. So the session will be data frame 1 and we will be discussing about data frames. Okay, so from the RD's perspective, what we know, like these over here, we are not having a proper schema, no proper schema dealing with say unstructured data and lower level construct from Spark side. Okay, so this is nothing but RDs, but once we are talking about data frames, so RDs are not having a schema. Once we impose a structure onto RDs, so let me pick data frames. Data frame. Once we impose a proper structure on RDs, then it will become a data frame. Or in another words, what I can say, we are having a proper schema over here. So these Spark data frames were introduced in Spark 1.3. Okay. However, like the usage or utilization started from Spark 1.6 and we are extensively using in Spark 2 and 3. Data frames are being used in Spark 2 and 3. Extensively usage is there of data frames. Now over here, what I can say, this is, let me mention over here. So introduced in Spark 1.3 and we need to have Spark session required in order to work with data frames. Okay, so previously once we were working with RDs, we need to have Spark context. Spark context was used to work with RDs. Okay, so Spark context and Spark session. What is the meaning of this? Can anybody explain? What is the meaning of Spark context and Spark session? What do you mean by Spark context and Spark session?
Both are entry point.
Entry point for data frame.
Yeah, so Spark session is the entry point for data frames, and Spark's context is the entry point to the RDs. Once we are working with RDs, then Spark context will be the entry point. So once we have gone through with certain examples with RDs, then we were creating Spark context over there. Just have a look over here, like we are creating Spark context now. But once we will be working with Spark data frames, then we will be going to create Spark session over there, and that will be the entry point. Without Spark session, you will not be able to work with data frames. And onto the the shell scripting, onto the shell scripting, we already have Spark context and Spark session. Just have a look. So just have a look over here. Spark session is available as Spark, and Spark context is available as SC. Okay. So inside the shell scripting, we already have Spark session and Spark context, but once we will be working with IDE, okay, integrated development environment, then we need to define Spark context and Spark session based upon the stuff or the flavor of API which we are using. If we are using RDs, then we need to create Spark context. And if we are working with data frames, then definitely we need to define Spark session. We need to create a Spark session. So this is a basic, but once we are talking about the differences between both of these two, certain differences are there. Let me mention in this particular way. Say we are having a feature, and on top of this we are having say RGD and data frame. So we will be having better clarity about both of these two stuff. So feature. So once we are talking about say versions, versions. So in Spark 1.0, we were having these was released inside Spark 1.0, and in Spark 1.3, we got data frames. However, like the functionality was started from 1.6, these are available, but nobody was working onto the data frames at that moment. They were having limited functionality. So after 1.6 or in 1.6, the usage or the working on to the data frames has been started. Then representation of data, how you are going to represent the data of data. So over here, distributed data elements, we know it very well. Distributed data elements in memory collection of elements. This is nothing but RD. But over here, data elements are organized in columns. Data elements are organized in columns. We are having data in tabular format over here. So if we are having this particular say sheet, then what we can say, this is nothing but like we will be able to work with RDs based on this particular sheet. And if we are having the file in this particular format, Okay, so we are having this particular format, so we will be able to work over here. It is organized in terms of rows and columns, huh? These are rows and these are columns, huh? Okay, you can extract, you can work with RDs as well over here, but you will not be having a proper structure once you will be working with this particular file or data set with RDs. Then you will not be able to map a structure over here, huh? But once you will be working with data frames, then a proper structure will be there, huh? Okay, so data is organized in terms of columns over here, huh? Then moving further, formats of data. So we can have structured and unstructured data, but over here we will be dealing with structured and semi-structured data. Okay, so we know it very well, like it will not be able to work data frames. With the help of data frames, you will not be able to work with unstructured data. We need to have structured or semi-structured data once we are working with data frames, huh? Then lazy evaluation, huh? What is lazy evaluation? What is lazy evaluation?
Execution will happen only after action.
Huh, that is fine. So what do you think, it will be available in RDs and data frames? So RD we know. What about data frames?
Same, yes.
So we will be having lazy evaluation over here as well, huh? Then schema, we already know it very well. Schema, do we have schema in RDs?
No,
No.
We don't have schema, but over here in data
yes.
frame we are having a proper schema. Okay, ease of use, huh? Okay, once you will be working with RDs, okay, so lower level APIs will be utilized, huh? Lower level functional transformation will be utilized, huh? And once you are using lower level functional transformation, then it will be a little bit typical to use, huh? So what I can mention over here, lower level API functionalities transformation transformation and with this, what we are using, higher level or higher order or level functional transformation, so once you are using higher order or higher level transformation, then it will be a little bit easy compared to the RDs, and in yesterday's session as well, I have mentioned that once we are working with data frame, then it will be very much easy compared to the RDs, so you will be loving to work with data frames with respect to the RDs. RDs are a little bit typical, huh? Okay, so performance perspective, huh? If we are talking about performance, huh? So we are having a engine that is tungsten engine or catalyst optimizer, huh? Inside the Spark, what we are having catalyst optimizer, huh? So RDs are not having the benefit of catalyst optimizer. Okay, RDs code is directly given to the core and it will be executed, but data frames and Spark SQL is having the benefit of catalyst optimizer. Let me show you one diagram. Catalyst optimizer. Okay, so just have a look onto this particular diagram. Over here, like if we are having something in SQL or data frame format, or if the code is there in SQL or data frames, then it will be passed through these particular steps, and then it will be converted into RDDs, and then RDDs will be executed. If you are having something in RDDs, okay, if your code is written in RDDs only, then you will not be having the benefit of these particular steps. Okay, so we will be having a detailed discussion onto the catalyst optimizer, no need to worry. But at this moment, at this point of time, what I can say, RDDs are not having the benefit of catalyst optimizer. So so the performance, from the performance perspective, data frames are more performant than the RDDs are. Okay, so performance not having the benefit of catalyst optimizer, having the benefit of, or has benefit of catalyst optimizer. Okay, so data frames are having the benefit of catalyst optimizer. Now with respect to the sport and all, sport, what I can say, public sport, or the forum sport or community sport. So RDDs, we are having less community, okay, to of the persons who are working onto the RDDs, but with respect to the data frame, we are having huge community who are working onto the data frame. So we are having large sport once we are working with data frames. Then you can mention the community size as well, community. So l- less community, just give me a minute. Okay, sorry guys. So the community size is, uh, you can say, less over here, and over here huge community is there. Huge community. Okay, so these are certain differences between RDs and data frames. Now let me try to proceed with certain examples. Data frame. Okay, so before moving with examples, in PySpark world, there are three main steps only. Or in designing any applications, we are going through with three steps. So what are those three steps? We are taking inputs, or say reading the data. Then what we are going to do, we are uh, applying transformation, and then writing the output. Writing the output. Okay, flow of any application. What I can say, flow of an application. Okay, in this world, the application which is designed will be having these three steps. Okay, reading the data, applying transformation, and writing the output. So reading the data, that will be, say, input. In our case, it will be the input. Then applying transformation, that is nothing but processing, and writing output is nothing but, say, sharing output, sharing, or the output part basically. Okay, so writing the output or output, these are nothing but like the process data will be written somewhere, or it will be shared with in terms of, you can say, reports, charts, dashboard, and so and all. Okay, so these are the three steps in any application which is designed in this particular world. From the PySpark learning perspective, okay, or in order to process the data with data frames, we will be moving with these three steps only. Firstly, like what we will be going to learn, like how to read the data. Okay, then we will try to apply the transformations over here. We will be talking about different optimization techniques over here. Okay, how a query will become more performant. We will be talking about all of these particular things. Then once we are able to process the data, then we will be trying to share it with the customer, or we will try to publish certain charts. We will try to save it in terms of, you can say, reports. We will apply, or we will you can say apply certain machine learning algorithm onto top of this particular data, or what I can say, we share it with the data science team, which will apply the machine learning algorithm. And then uh, the the you can say BI team, a business intelligence team, so which will be trying to get certain insight from this particular data. So our main motto, or the main things, what it will be like: reading the data, processing the data, and sharing the output. Okay, so these three steps are there with respect to the data frames. In order to learn data frame, we just need to keep these three you can say phases in our mind, and then we will be able to get the insight, like how to work or how to design an application. Okay, so just have a look what we are having. So we are having a certain data. Okay, let me try to mention, create, say we are having data, and data is given, say, in terms of a list. And what I can say, okay, so what we are having a list, and in this particular list, what we are having, certain data. And I can mention, say, name, it will be name, then city. Okay, say Ram, and then city is, say, Delhi. Okay, I'm going to create certain dummy data. Okay, and say age, age is, say, 30. In this particular way, I'm going to create certain data. And I can change the name. Let me paste it inside the ID. Okay, so from spark.sql, from PySpark.sql, import Spark session. Okay, so as we are working with data frame, so we will be going to import the Spark session. Previously, once we were working with RDs, then we were creating the Spark context. So I am going to mention this Spark, that will be Spark context, Spark session dot dot builder dot app name. Okay, and I'm going to provide an app name over here, and say I'm going to give master as well, master, and it will be master is, I'm running onto the local. Okay, I'm running on local dot, and I can give the app name. App name is, say, first data frame code, okay, and dot get or create. Okay, so we can write it in a good way so that you will be having better visibility. Okay, so what we have done over here, we have created a Spark Spark session over here, and the name for this particular Spark session is Spark, and the application name over here is the first data frame code. So over here inside the in the shell scripting, the application ID is this one. It is running local onto, and this is the ID. And master is local. Okay. So over here, master is local and app ID is this one, but we are creating the Spark session over here. So we have given our name. So it will be like application name will be first data frame code, and master, that is local over here. Uh, the star is denoting the number of cores. If we are mentioning say local one, so this application is going to use one core from your machine. If you are going to mention two over here, then this application is going to utilize two core from your machine configuration. Okay, so star, it is going to take based upon the availability, and we will be able to work on. Moving further, okay, so this is nothing but a particular uh, data or a list basically, which is having certain records. And let me mention over here. Okay, so for the visibility perspective, I'm going to change it in this particular way. Okay, so at this moment, we are creating a data frame by mentioning the records, but we will try to read the data from certain files and all. Okay, there will not be any issue. Okay, so let me change the name, say Pankaj. Okay, and we can say Gaurav, then say Vikas, and say Rohit. Okay, so say Ashok, what I can say, and Akshay. Okay, and we can pass any age. Okay, so we have given certain numbers. Okay, Jaipur. Okay, I'm just passing the dummy data. Okay, so this is a list what I'm having, and it is having certain records. Now, what I have mentioned inside the data frames, once we are working with data frame, then we need to have a proper schema. Okay, so in order to define the schema, what we can do, we can have different techniques to define the schema. Okay, on top of this particular data set, we are having different techniques to define the data set. At this moment, friends, we are going through with reading the data. Okay, so reading the data is the first phase what we are going to learn at this moment. So reading the data, so we need to define the schema. We are having certain data, and now we need to define the schema. In order to define the schema, we are having three main formats or three main techniques for the schema definition. Techniques to define the schema. Okay, first one is uh, that is infer schema. Second one is programmatically define the schema. Defining the schema. And third one is with DDL string. Okay, with DDL string. So at this moment, we will try to use this one, programmatically define the schema. Okay, so what you just need to understand, in order to define or programmatically define the schema, what we need to do, we just need to have the understanding about the data type and all about each and every field. Okay, so let me proceed with programmatically defining the schema. Okay, so over here, we need to utilize certain classes. So one of them is struct type. So struct type is having certain fields. With respect to the fields inside the struct type, we just need to mention these particular you can say fields. Let me mention. So I'm going to define the schema for this particular data set. So that is equal to over here it will be good. So schema, it will be equal to struct type. I just need to import this name. Okay, let me first import PySpark.sql.types import string type comma struct type comma integer type. Okay, so I'm going to use struct type, and inside the struct type what I am having, I'm having different fields. So with respect to each and every field, I just need to mention. So struct field I just need to import, that is with respect to the column name. Okay, struct field. Okay, struct field and the field name you need to give. Okay, so the field, I'm going to say the first column, it will be say name. So name, say learner name or the name. Okay, so name, and what will be the data type for this name? That is string. Name.
Yes,
First column
string,
is name, string. So
string.
over here, with respect to Spark, if like data type is string, then we need to utilize string type. So it will be string type. String type, and this is the string type. Otherwise, string type, and it must be say true. Okay. So these are certain the formats. Once you will be working, you will be able to get the understanding. Then second one is the city, and say third one is the age. What I can say age, and over here it will be say integer type. Okay, so integer type, perfect. So the
Ashok, why
schema.
we use true? True. Do we need
Okay,
to
it
use
is
this true?
like we will be having the records. Otherwise, like if we are not having the records, then we can mention none over here. If like blank records are there, then like we can mention none. Right, are you able to get? So it might
What
be
if we
possible.
don't mention true? What if we don't mention true? Only string type. That's it, or is it
Yeah,
mandatory
it
to
will
mention
work.
true? Or
It will
it will
work.
work. Okay. Okay.
Hmm. Okay, Just give me a minute. Okay, so let me proceed. You can try it without true. Okay, it will work. There will not be an issue.
What is
So
true
we are
false? Can
having
you please explain? Sure. It's nullable
actually
type I have, but what is the meaning of nullable type? Actually,
where label type.
nullable type, nullable, null value type, something I have learned from.
Actually, what I have mentioned this, but if like we are having none value over here, okay, if we are having null value and if we are mentioning true, it will not be, it is not going to, you can say, consider the null values. If we need to consider the null values, we can mention without true over here, right?
Can you check once?
Okay.
First run the code and then check once. First run the code what you are
Hmm.
doing, then
Okay.
thank you.
So what we are going to do, Spark, say data frame, or what I can say mention df equal to spark dot create data frame, and I will pass my data and this particular schema. Okay, schema equal to schema what I have defined. Okay, so now df dot show it will list top 20 records from this particular data, and just have a look. Okay, so we are able to get this particular outcome. Okay, we are able to get the data frame. Now you are talking about say true, false. Okay, what we can mention. So over here, if we are having null values, okay, so say I am going to mention false, and what will be the meaning for this? If we are having null values, so specifying what we are going to do, we are going to specify false for non-nullable. Okay, so just a minute. You just try to, okay, now we can mention it. Let me try to have certain null values in this particular data. Okay, say we are having null over here, that is a blank value. Okay, none, or I can have none over here. Okay, none, I can have none over here. None. Okay, so the main difference once we are going to use true and false will come with respect to these none values. Okay, now if I have used true, then just have a look. The outcome will be, it will look like this. You will be having none once you are having none values. Okay, it will give me none. The outcome will be none. Okay, null. The outcome will be null. Okay, so the outcome is null over here. Once we are mentioning true, okay, once we are mentioning true, it will be null. Once you are going to mention false, okay, false, then it is going to give me false. Okay. Okay, so the field name, this field is not nullable but given none, right? So if we are mentioning true, so it will be able to accommodate the null values. Okay, it will be able to accommodate null values. Okay, and if we are mentioning false, so it will not be able to accommodate null values in any field. Okay, and what is the meaning of false over here? False is specifying false for nullable. Okay, are you able to get? It means true means we are accepting the null values. If we
Okay,
are having,
understood. Understood,
if
Ashok.
we are having certain null values, none value, it might be possible. We are not having the understanding about that. Like we, until unless we are not reading, we will not be able to judge that data is having null values or not. Over here we are restricting that the date that this particular column will not have any null value, right? And same is mentioned over here. Like the field name, this field is not nullable but got none. We set it to not nullable. We set it to not nullable. Like it will not have null values. But in the data we are having null values, none values. Is it clear with everyone?
Yes, Ashok, clear.
Okay,
Yes, yes,
so
Ashok.
okay, so false, huh? No, true, huh? It will be true. So we used to set, this is the normal practice. We used to set it to true, huh? Okay. So if we are having certain null values, it is going to consider and we will be able to get the data frame. Okay. Okay. So we are able to read the data. We are able to create a data frame on top of a given data. Okay. Now, now the main thing is that, like, in order to read the data, what we are talking about, so over here we try to read the data, we are try to create a data frame based upon a data given. So we are having this particular data, and with the help of this particular schema we are able to create the data frame. So this is good from the learning perspective. So we are having certain data and we are going to create the data frame on top of that particular data. Okay. Another, you can say, approach is with DDL string. We can define the schema with DDL string over here. Okay. So just have a look. So this is what programmatically defining the schema. Schema, that is perfectly fine. Now the second, what it will be with DDL string. Okay. So DDL string. That is the second way in order to define the schema for a particular data set. Now, what I can say schema equal to, or say DDL string, what I can say, DDL string, that will be nothing but schema, and I can define, say, uh, I can define, say, name that will be of string type, then say city, it will be of, say, all again string type, and then what we are having, age. Age is of, say, integer type. It's just very simple in order to define the schema with DDL string. Then the same stuff we just need to utilize. So spark dot create data frame, and instead of schema we are going to pass DDL string at this moment and df dot show. Okay. So based upon the flavor of data, we just need to define this particular schema, and this is like the DDL string format. We are going to define the schema as a string. Okay. So just have a look, and we will be getting the same output. Okay. So just have a look. So name is city and age, and how we have defined the schema with the help of DDL string. Over here, we are not having the concept of nullable and all. Based upon the data, what is given, it is going to consider that particular data, and we will be able to get the output as a data frame, PySpark data frame. So DDL string is this particular format, okay, and the first one is programmatically defining the schema. Let me paste it over here. Let me paste the code.
Ashok, is there any advantage over first, like problematically over this DDL?
Both of these two are the methods. Over here, we are leveraging the traditional data types, and inside the struct one, we are using the PySpark inbuilt data type. So once we are using the PySpark inbuilt data type, so it will be a little bit more performant, but no major, you can say, issue is there. Okay, a little bit more perfect, because you can think in this particular way. Over here, once we are defining the schema with programmatically, okay, so we are using the PySpark inbuilt data type. Okay, once we are working with inbuilt data type, then performance perspective, that is better. But there is no major gain. Major notice gain is not given, because this is the schema definition only. It is not like we are processing something, right? It is a definition defining the data within the inbuilt data types, or Spark uh, traditional data types, that can provide minor, you can say, functionality improvement, but no major improvement is there. But the the benefit is from the definition perspective. So with respect to the definition, it's easy for the developer to define the schema, okay, with DDL string. Now, with respect to the defining, once we are going to define the schema with programmatically and using struct field, struct data type and all, so it will be a little bit complex process. Okay, there are the chances to get errors. Okay, from the performance perspective, no major difference is there. It
Right.
depends
Which
on you
we usually use
which
this DDL or this programmatical? Which one we
it
use?
depends upon person to person. Like if
Okay,
you
we can
are
use
okay
anyone.
with if you are okay with DDL string, then proceed with the DDL string. If you are happy with the programmatically defining the schema, then that is also fine. This is definition only. With
Only.
respect to the
Okay.
definition, there is no major difference.
Mhm. Okay.
Ashok, this is three inverted comma. Is the is for all the this is for all the like it is fixed for all the context or only for the
Preferred is
which
3,
case?
but you can define with one inverted comma as well.
Okay, okay.
Okay, so this is nothing but programmatically defining the schema, and this is schema definition with DDL string now. Okay. Now that is fine. Now, so what we have seen at this moment, like we were having a certain records, we were having some data, and on top of this particular data, we have created the data frame, Spark data frame. On top of this particular data, we have created a Spark data frame. Now, in order to read the data from a particular location, we are going to leverage Spark or PySpark standard data read API. Okay, so PySpark standard data read API. Just have a look how you will be able to read the data with the help of PySpark standard data read API. Okay. So what we are having, what we are going to learn, Spark standard data read API. Okay, so we will be going to utilize this standard data read API in order to read the data from the different location, from the different for the different file formats and all. So what is this Spark dot read? That is the standard data read API, and what it will be over here, we are going to mention say dot format, and now we can mention the format say CSV. Okay, if you are having the JSON file, you can mention the JSON over here. If you are having any other format, then you can mention any other format. Okay, Parquet, CSV, Avro, okay, ORC. The format is like you just need to change that this particular keyword, then you will be able to read that particular file now. Then we will be having certain options, option and say header, header, and header is say true. Okay, if the data set is having header information, then you can set it to true. Otherwise, you can set it to false. Okay, then dot option, and over here what we are having is infer schema. One keyword is there, infer schema. Okay, so we have talked like we are having three main techniques to define the schema. Two techniques we have gone through with two techniques like programmatically defining the schema and with DDL string. Third one is inferring schema. Okay, infer schema, and it can set to true and false. Okay, then true, that is perfectly fine, and then dot option, and what we are having mode, so we are going to read the data into different modes, and mode can be say permissive, fail first, drop malformed. So say the mode is permissive at this moment, permissive, and then option, and we just need to mention the path of the file where this particular file is existing, and we just need to mention the location, location, and then dot load. Okay, so dot load. Okay, whatever file we are having, we will be going through with this particular Spark standard data read API in order to read the data. Once the data is there, then we will proceed with the second you can say phase, that is nothing but applying transformation or processing this particular data. So reading, say if we are having certain data, we will be able to create data frame, then we can proceed further. If we are having data that is given in a file, then we will be able to read this particular standard data read API. Okay, let me copy this and paste it inside the IDE. Okay, okay, and let me mention this. So say data or reading data, that will be my data frame, reading data, and I'm going to read spark.read. Okay, and let me try to mention in this particular way. Okay, things are looking fine. I just need to change the path. Okay, so location, so say I'm having certain data, let me try to check some data over here that is having some, so it is not summary, summary is not there. So what I can have, I am going to take certain data, say car trans, mobile phones, Okay, let me take this one, a 2GBBH new. That is without columns. I just want to have with columns. With header information, I just want to have. So this is the file what I'm going to consider in order to read. Copy and let me paste it inside this particular path. And 2GBBH, that is the CSV file, comma separated values. And what I'm going to do, I'm going to provide this particular path over here and the path, the file name, CSV dot CSV. Okay, and let me change the path into Spark understandable format. Okay, so that is perfectly fine. Reading data dot show. Okay, so and just have a look. Okay, so just have a look over here. Now we are able to read the data: serial number, date, BSc name, 2G site name, 2G cell name, STCCH call rate, drop call rate. So what is the meaning of infer schema over here? So infer schema is going to specify, or it is going to infer the schema that is given inside this particular sheet. So Spark is doing what? Over here we are choosing like this particular field will be of string type, this particular field will be of integer type. But once we are going to utilize infer schema clause, then Spark is going to check the records which are given in the data, and based upon Spark understanding, it is going to define the schema for your data set. Just have a look. So if I'm going to check the schema or for this, so we are having a function print schema. So just have a look over here. So print schema is going to provide me the information about each and every field, the data type of each and every field. So just have a look. Serial number is of integer type, date is of string type, BSc name string type, 2G site name string, SDCC is drop call rate double, drop call rate double. Okay, a nullable true, nullable true. So we can have null values, nullable true, nullable true. We can have null values as well. So Spark has defined the schema based upon the data set which is given in that particular CSV file. But if you are not happy with this particular stuff, then what you can do, you can define the schema of your data, and then like the code will be going to work on your data. So over here, say date is considered as string. Date is considered as string over here, but if you are not happy with this particular data type, then you can change it. So over here Spark is going to analyze the data first, and based upon Spark understanding, it is going to infer your schema. It is providing the data type to each and every field which are mentioned. And irrespective of this, say with DDL string, if you are going to say print schema, df dot print schema, and just have a look, it will be going to say name string, city of string, and age is of integer type. Just have a look, and we can define age as a string if we want. So over here we are defining the schema for this particular data, but inside this particular example we are leveraging Spark functionality, that is infer schema, in order to provide the data type to each and every field. So just have a look over here. Over here, like say name is of string type, city is of string type, age is of integer type, and we have defined this. We have defined this particular schema for the given data. Okay, if you want to change it, then like the same data, same you can say can be same data type can be applied. Infer schema is not, you can say, a good approach inside the production environment. From the learning perspective, you can proceed with the infer schema, but it's better to define the schema of your data, and then that particular data type which you are going to provide to a field will be utilized for the further processing. Basically, what we need to do, we need to do the processing in the next phase. What we are having, applying the transformations on top of the data. Okay, so in the next phase, like if there is mismatch in the data type based upon the Spark understanding and what you are willing to have, then the errors will come up. Okay, so better you can choose to define the schema of your data, and two approaches are there. Either you can proceed with programmatically defining the schema, or you can define the schema with DDL string. Infer schema, that is you are aligning Spark to define the schema for your data. Okay, let me mention infer schema. We are, or Spark is going to check the data, and based upon Spark understanding, it is going to infer or define a schema for each and every field. Okay. Okay, so that is nothing but infer schema. So what we have seen from this particular Spark standard data, Spark's standard read API format, like you can mention any format over here based upon the file that you are having. If the file is having header information, then you can mention header true. Okay, if the header is not there, then you can mention header false, or you can remove this particular line. Infer schema, you are trying to infer the schema based upon the Spark functionality or Spark understanding. Mode, so with respect to mode, there are three main modes, or what I can say, read mode, read modes. Okay, so once we are reading the data, then there are three main modes: permissive, fail fast, and drop malformed. Okay, so permissive, fail fast, and drop malformed, these are the three modes inside the Spark once you are reading the data. Okay, so permissive, this is the default mode, the default mode. And if you are not mentioning anything, then this mode will be considered. So in order to move with this, let me try to show you some data. So we will be moving with some data that is JSON file, players.json. JSON file, it's not there. Players.json. Let me copy this file and paste it over here. Okay, so we are having this particular file players.json. Okay, so let me try to read this particular file. So reading data. Now what we are having, reading data with PySpark standard data read API. Okay, now what we are using, we are trying to read the data, that is JSON data. So what we need to do, we just need to copy and paste this particular code. You just need to pay attention, and let me give a name to say players data frame. Okay, players df, and it is of JSON type. And instead of this, what I'm going to have, players dot json. Okay, and let me try to comment the rest of the things. I don't want to see reading data, and I just don't want to see df as well. I'm willing to have players df, players data frame dot show and players data frame dot print schema. So at this moment, what I'm going to do, I'm going to read the JSON file. Header is true over here, infer schema true. Okay, and mode is permissive, and this is the path for the players JSON file now, players.json file now. Just have a look. Okay, so what is the data? So this is the outcome once I'm using the permissive mode. Okay, so permissive mode, what I have mentioned, I was having certain players data. Okay, that is in JSON format. Now if I'm using the permissive read mode, so it is the default mode. If you are not mentioning anything, then it will be considered. And what it will do, uh, it is going to read the data even it is corrupted. Okay, so what we are able to see, we are having corrupt records in this particular data. Okay, we are having certain corrupt records, and why these records are corrupted, because certain issue is there with respect to the format. So Just have a look, players, and let me open it with the with Notepad plus plus. And what we are able to see over here, so the red is denoting, say, we are having corrupted records. So if the format is not correct with respect to the JSON, say players ID over here like blank is there, over here instead of say integer values it is passed, say xxx is passed down. So the formatting has been changed. Now JSON file JavaScript object notation, a file is expecting the input with respect to each and every field, and they must be uh, be mapped with the data type and all. So in the JSON file we used to have the same data type in a particular column, but if that is not matching, then the JSON file is corrupted. It might be possible some records are missing and all. So JSON format is corrupted. So over here we are having certain corrupt records, but once we are leveraging the permissive mode, then it is going to provide me the corrupted records as well. It is not doing anything. Okay, whatever we are having in the file, it is going to provide me. And this is the default mode as well. So if I'm going to remove this particular permissive statement or clause from here, then also it will work. Okay, just have a look. So I have removed the clause permissive over here, and just have a look. So it will provide me the same output. What we are going to do over here, we are trying to read the different read modes. We are trying to learn the different read modes, and there are three different read modes: permissive, fail fast, and drop malformed. So permissive is the default one, and if the file is having corrupted record, it is going to provide those records as well. Okay, so say if you have removed the the permissive clause, then also we are able to get the same output. That's why, like I have mentioned, this is the default. If you are mentioning it, then that is fine. If you are not mentioning it, then also it will work. Okay, so Control Z. Okay, so permissive. But
Ashok, why we
once
are
we are
taking this print schema at the end? This player df dot print schema.
okay, so that is like in order to provide you the information. Say corrupt record is also taken as a record. Is
Okay,
nullable. Okay, so
okay, but
and
that
that
is
is,
not mandatory, no, to take. We can
yeah, that is
just
not mandatory. We are just trying to learn the different read modes. Okay,
all right.
okay. So let me remove this. Now, the mode, let me mention, say fail fast. Fail fast. So if fail first is doing nothing, if the file is having corrupted records, just have a look. You will not get anything if the corrupted records are there in the file. So the execution has been started. Just focus onto this particular button. Okay, and soon it will be executed, and we will not get anything. Okay, so we are not getting anything. Okay, we are not getting anything, and like error is certain error is there. Job aborted. Let me try to show you the correct error. You just need to just have a look over here. So unexpected character and all, and unexpected character, you will be getting the error caused by JSON. JSON parser exception. So parser exception is there because like you will not be getting anything. Drop malformed, it is like going to nothing will provide. It is going to trigger the error. Okay, like the records are corrupted in your data set. Okay, let me mention over here. Fail first. Fail first. If the records are corrupted, then it will not provide any output but raise some exception that records are corrupted. Okay, we will not get any output. So previously, once we were using fail drop permissive, so we got this output. But fail first will not provide you the output. Then drop malformed. Drop malformed, what it will do, it will remove the mal records, corrupted records, and you will be getting the output free from the errors. So just have a look. Now we are using drop malformed. Okay, so just have a look. Over here, the mal records has been removed. This is the output of drop malformed. Now this is the output of permissive mode or default mode. This is from drop malformed. So it is going to remove the mal records or corrupted records from the given data set. Okay, so you will be getting the records which are free from errors. So 30, 25, 30, 38. So these are the records which are free from errors. This is also, you can say, corrupted record. This is also the corrupted record. So at this moment you are getting the outcome free from errors. So this is the third read mode which we are having in the PySpark. So what we have seen in today's session, like what is data frame? Okay, what is data frame? Difference between RDDs and data frame. Data frame. How to create Spark session. Okay, how to create data frames with dummy data. How to define schema. Okay, and from the schema perspective, what we have seen? Infer schema, programmatically defining the schema, defining the schema, and with DDL string. Okay, then how to read the data with standard data read API. Okay, and over here we have seen the read modes, and with respect to the read modes we have seen permissive, fail fast, and drop malformed. Okay, drop malformed. Okay, so these are the things what we have seen in our today's session. I think that's it, what I want to cover. What you need to do, you need to write down certain codes. You can take the sample data from internet. You try to create Spark session and create data frames on top of that particular data. Leverage infer schema, programmatically defining the schema in DDL string, and try to go through with the different read modes. So today what we have seen, we have gone through with the first, you can say, module, that is the input. How we will be able to take the input. Once we are having the input, now what I can say, we are having a particular input in the form of, you can say, data frame. Then we will proceed further in order to apply transformations, and it might be, say, we are applying filter, we are filtering, we are adding two columns, we are creating new columns, okay, we are applying group by, order by. That is nothing but processing of the data frame. So once we are able to process, then we will be going to write it onto the different locations. So that will be the flow. Try to have some practice during weekdays onto these particular topics, and you can ping me if you are having any confusion. Data frames are very simple, and definitely, like, the questions will be there during the interview. From the examples what we are covering in our classes. Okay, so these are the state forward interview questions, like what is the data frame, difference between RDs and data frames, what is the permissive mode, what is happening once you are applying infer schema. So these are the straightforward interview questions. You need to have the practice on to these particular things, and that's why, like, I have keep on mentioning from like in the starting and in the end of the session, I used to mention these particular topics. So prepare well, and start practicing from the interview perspective as well. Whatever is mentioned over here, okay, try to explain it in your words, okay, your language, and once you are able to explain, then try to write it. Try to prepare your own notes with respect to these particular questions. These particular things definitely will be there in interview. I will be sharing some interview questions as well, but before this, you need to have the practice what is being covered inside the class. That's it for this particular session. If you are having any doubt, you can ask. Pankaj, I think Naresh
Ashok,
is there.
one,
Mm-hmm.
Ashok, I have one question.
Mm-hmm.
While writing the data read API, we have two elements are there. One is header is true. Second one is related to schema, infer
Mm-hmm.
schema. What is difference
Mm-hmm.
between header and schema? It means head is, uh, infer schema means it automatically read schema from the data if infer schema is true. So
Okay.
my confusion, what is header and what is schema actually?
Actually, like, if you are not having header and you are going to define the schema, then what you need to do, you just need to remove these two clauses. Okay, if schema is not there, and you just need to mention, say, schema equal to the schema what you have defined, right?
Okay.
Okay, schema
Dot,
is,
dot schema. Dot
did you,
schema is I think an
okay,
option. Dot schema
what
is
what
I
what
think
what
dot option like dot format. We have option
yeah, yeah,
dot
in this
dot
particular way
schema.
as well we will be able to define,
Okay.
right? Multiple ways are there. You
Mhm.
can mention the schema over here as well.
Okay.
Okay, you can define it. So it will be like this. Let me share the correct line of
I
code,
have
piece of code.
confused like what is header and what is schema because both are
Header
similar.
is like, if you are not okay with the header, okay, then you can set it to false,
Okay.
and you can define your own schema.
This header is it is picking from the data set itself, right, Ashok? header
Yes,
true.
yes, yes, from the data set
Uh,
itself.
yeah, and infer schema is also referring the same header from the data set. So I guess this Gaurav is also asking in we mentioned header true, infer schema true. So is there any difference between these two, or if we remove this header true, will it still take the
It
header
will
from the?
provide it will provide the data in this particular way. Okay, okay, just have a look. Now let me show you. CSV. Now you will be able to get a.
Okay.
Okay,
Hmm?
this it is considering that first header in the database as a values. If we make
First
first
row
row, sorry,
is
first row,
considered
yeah,
as
as a
as
data set.
header. Okay,
Hmm.
the JSON is not having that particular structure, so it is providing the same. So that's why I moved with CSV. Yeah. So in CSV, like if you are mentioning say this particular row as header, so we were having this particular data as well. Huh? So it might let me show you. So
Clear, clear.
we are having this particular data. This is not having header, right? In customer order you will be able to get in a good way. So this is not having header information. Okay. On top of this, if we are aligning Spark to infer schema, so it is going to check each and every field, and based upon understanding, it will provide and it will infer the schema. Okay. Now over here, Spark is going to infer in a incorrect way. Just have a look. So each and everything is considered as string. Why? Because we are having string information in the first row. Hmm? We are having a row and its values are string. So if we are considering it as a data, so Spark will check string is sr underscore no, that is the string data type, that is string. So with respect to this, it is not going to check it is going to check the others as well, so if string is there, the string is given, because like one can be represented as string, but string can be represented as integer, right? Is it
Right,
fine?
Ashok. Right.
Okay, so infer schema is like inferring the data type with respect to the column information. Header is denoting the first row. If your data set is having first row, then it is fine. Otherwise, it is going to create C1, C2, C3 columns with respect for your data set. Okay, so if we read this particular data, so it will be C1, C2, C3. Okay, I should have taken this particular data set, but you will not be able to understand the meaning of C1, C2, C3 at that moment. Intentionally, this particular data set was taken, and I have copied it from the different location, right? So try to understand the concepts. Okay, fine, clear?
Yes, yeah, clear, Ashok. Fine.
Clear,
Okay,
Ashok.
perfect. So that's it for this particular session. Okay, is there any issue, any doubt, any confusion?
No, sure, fine, super.
Okay,
It's fine.
okay, okay. Let me stop recording.